Hi, welcome to Mrs. Park's Algebra 1 class. This is finally Chapter 8. We're moving on to Section 1, Monomials and Factoring. Okay, so when we will use this? Susie's making beaded bracelets for extra money. She has 60 gemstone beads and 15 glass beads. She wants each bracelet to have only one type of bead, and all the bracelets have to have the same number of beads. Susie needs to determine the greatest common factor of 60 and 15. So before in middle school, we learned how to factor with just numbers. So now we're going to move on to how to factor numbers and monomials. Well, factors and variables. So factoring monomials. Factoring a monomial is similar to factoring a whole number. A monomial is in factored form when it is expressed as a product of prime numbers and variables, and no variable has an exponent greater than 1. Okay. So here, if you're factoring negative 20, okay, negative 20, and if you remember how to do a factor tree, you can use that. So I'll go with 2 first, 10, and you have 2 and 5. And these are all prime numbers, 2, 2, 5. So 20 is factored into 2 times 2 times 5. Okay. And that's exactly what we're doing. We're just factoring the number first. You have 2 times 2 times 5. But because it's negative, so you add a negative 1. Okay, so then we're done with the numbers. When it comes to variables, excuse me, we're going to factor x cubed. That means there's 3 x's that are multiplied. Y squared means there's 2 y's. Okay, so the factor form is just this. You're just breaking down each number or variable. Okay. So here's your term, 1a and 1b. So first you gotta factor the number, and then you gotta factor the variables. So this would be x, 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 y, 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 with the numbered factored. Okay. If it's a negative, make sure you put a negative 1 there as well. Okay, so go ahead and do numbers 1a and 1b and come back when you're done. Alright, welcome back. Greatest common factor. 2 or more whole numbers may have some common prime factors. The product of the common prime factors is called their greatest common factor. And we are familiar with GCF, greatest common factor. This is the greatest number that is a factor of both original numbers. The GCF of 2 or more monomials can be found in a similar way. So here you have 12a squared b squared c. You have 18ab cubed. Okay, so you're going to find the greatest common factor for these two. Alright, so we break down the factors for each term. You have 12 is going to be 2 times 2 times 3. You have a squared, a, b squared, bb, and you have c. So you lay out all the factors. Second term, 18ab cubed. You have 18 is breaking down to 2 times 3 times 3. A, there's only one way, and b cubed is 3 b's. Now what you're going to do is you're finding what they have in common. So you have a 2 in common, a 3 in common, 1a in common, and 2 b's in common. Okay. So this is the greatest common factor. And this is expressed by multiplying all these numbers. So 2 times 3 is 6. A, there's only one a, and there's 2 b's. So 6ab squared is the final GCF. Alright, go ahead and do 2a, b, and c. You're finding the GCF for each pair of monomials. So if you want to lay out all the factors for each term and find what they have in common and have that multiplied as the final answer. So go ahead and do 2a, 2b, and 2c. Alright, here is a real world example where you would have to find a greatest common factor. Flowers. A florist has 20 roses and 30 tulips to make bouquets. What is the greatest number of identical bouquets she can make without having any flowers left over? How many of each kind of flower will be in each bouquet? Okay, so find the GCF of 20 and 30. So 20 and 30, okay, you can factor these numbers. And what they have in common is 1, 2, and a 5. And 2 times, oh, hold on. So the factors for 2, factors for 20, and factors for 30 is 10, because you have a 2 times 5, which is 10. So she can make 10 bouquets. Since 2 times 10 equals 20 and 3 times 10 is 30, each bouquet I have 2 roses and 3 tulips. Okay, so this is the last slide. This was a short lesson. So go ahead to number 3. Find the greatest possible value for the width of two rectangles if their areas are 84 inches and 70 square inches. So you're looking for the greatest common factor. Okay, and once you're done with this, you're done with homework. So today was a very short lesson, and make sure you put that in your book bag for credit for tomorrow. All right, then thanks for watching.